Hello, and welcome to a little video about Target 4D. Let's get started. Number 1. The average attendance at a local high school this year was 750 students. Each year, the attendance decreases at a rate of 0.4% per year. What will the average attendance be in 5 years? All right, let's set this up. The school starts with 750 students. That's what we're looking at right now, 750. Because it decreases, in my parentheses, I'm going to write 1 minus. Next, I'm going to put down my rate. Now, my rate needs to be changed into a decimal. Now, I know it looks like a decimal, but to get 0.4% as a real working decimal, we're going to 0.4 divided by 100, and we get 0.004. Right? And next, we are using the 5 as the exponent for 5 years. Okay, this all gets entered into our calculator, and what I get is 735.12. Now, it's not possible to have 0.12 of person, so 735 is our final answer because, well, whole students would be 735. Number 2. You bought a rare baseball card for $5,000. Each year, the value of the card increases at a rate of 0.8%. What will the value be in 20 years? Well, first we start off with $5,000. Because the card is increasing in value, my parentheses are going to get a 1 plus. Next, I have a rate of 0.8%. Now, when I convert 0.8 into a decimal, it becomes 0.008. And I'm going to raise it to the power of 20 since it's 20 years. Plug that into my calculator. Give me a moment, let me grab that answer. We get $5,863.82. Number 3. George gets $100 for his birthday. Each week, the amount of money decreases due to spending at a rate of 0.9% per week. How much money will George have after 15 weeks? Okay. So we begin with $100. That is a nice birthday gift. We're decreasing, so our parentheses will have a 1 minus. The rate is 0.9%. As a decimal, 0.9% is 0.009. And we're raising it to the power of 15 for 15 weeks. Now, I know, generally speaking, we've been using years more than we have been using weeks as our exponents. But that's okay. The exponent is a measurement of time. This time, in number 3, it's weeks instead of years. I don't know why I said this year. Anyways, type this into your calculator, and somehow, after 15 weeks, George has $87.32. Now, on our calculator, I actually got 0.138, and I rounded the 1 and the 8 to give me a 0.32. Number 4, Yolanda bought a new car for $40,000. Each year, the value of the car decreases at a rate of 14.5% a year. What will the value of the car be in 10 years? So Yolanda starts off with $40,000. And the value decreases, so I'm subtracting. The rate is 14.5%. That's a little simpler to turn into a decimal, 0.145. And I'm raising it to the power of 10 because of 10 years. Plug that into my calculator, and we get $8,350.67. Okay, number 5. Mary's car was worth $32,000 in 2010. The value of the car has decreased by 15% each year. The graph models the relationship. Let's use the graph to estimate which years the value of the car was half of 2010. All right, so first let's find out what half of 32,000 is. And that's 16,000. Now we're going to next is find 16,000 on the graph. Now this is kind of hard to see because it's going by fives. And in the real world, you might get graphs that aren't as detailed as you might like. So I'm going to assume 16 is somewhere right there. I think that's fair. I'm going to extend that line and see where does it cross my curve. It crosses my curve between this year and this year. Now, I would love to get more detailed than that, but I don't want to guesstimate because I'm not quite sure. So, 4 years since 2010 is 2014, and then 6 years is 2016. So don't put down a 4 and a 6. This is 2014, 2016. All right, number 6. The city of Beaverton has a population of 20,000 in 2005, but the population is decreasing by 15% each year. Let's use the graph to estimate when the population will double. All right, first of all, let's double our population. So times 2, 40,000 people. The graph is actually a little bit better than last time because we don't have to guess where 40 is. It's right here. However, this graph is still going by 2 years, so we're going to have a 2-year gap. All right, now this is years since 2005. 4 years since 2005 is 2009, and 6 years from 2005 is 2011. Now I want to guess between 2009 and 2010, but I don't know if that's accurate because our graph isn't detailed enough. Number 7. Norway has 1,000 registrations of plug-in electric vehicles. The number of registration has been increasing by 90% each year. The graph shows the relationship, and let's use it to estimate when it was 10 times larger, when it will be 10 times larger. So we're going to take 1,000 and multiply it by 10, for which we get 10,000. This graph is even nicer. This is more detailed than the other two. We have the 10,000. Beautiful. I land it on my graph, and this graph is going by ones. Thank goodness we're going to have a more accurate representation. 3 years since 2010 is 2013, and 4 years since 2010 is 2014. Let's write that down. All right. Number 8. The average attendance at your local high school this year was 1,250 students. Each year, the attendance decreased at a rate of 0.6 per year. What will the attendance be in 4 years? All right, let's check it out. We begin with 1,250 students. And since we're decreasing, our parentheses will have a 1 minus. 0.6 as a decimal, 0.6% as a decimal is 0.006. And we're going to raise it to the power of 4. Now, if you're ever unsure what a percent looks like as a decimal, remember, you can take that number and divide it by 100. That'll give you your perfect decimal. All right, I plug this into my calculator and I get 1,220.27, which doesn't make sense. We can't have 0.27 of a human. So 1,220. I guess more clearly, without causing any shenanigans, we can't have 0.27 of a high school student. That would, I don't even know how to imagine that. All right, last one, number 9. The city of Wichita Falls has a population of 60,000 in 2005. It's been decreasing by 9% each year. The graph shows it. Let's estimate when the population will be half of what it was. So let's find out half of 60,000 by doing 60,000 divided by 2. And we get 30,000. Right, this is a really nice graph again. I know it looks like this is going by 2s, but it really is going by 1s. Look at those tiny little gaps. It was sneaky. All right, so we have 30,000. That's also very nice. 30,000 lands right there on our graph, which is between the 6 and the 7. All right, so this is years since 2005. So 6 years since 2005 is 2011, and 7 years since 2005 is 2012. So our answer is, it'll be between 2011 and 2012. I hope this was helpful. If you have any questions, make sure to ask myself or your teachers. Otherwise, have a wonderful rest of your day. Bye!